Hey, I just want to give a shout out to Luke. What's up, Luke? Glad you're watching this video since you're not here in class today. What's up? Oh, he's got prom. Does he have prom? Is that the sections tomorrow?
Oh, their prom is today. It's today. Yeah.
Hope you and Chloe have a wonderful evening. Okay, so what we're going to be doing here, we're going to be finding a unit vector in the direction of v equals -2, 5. So let's take a guess before we ever start. What is a unit vector?
On the unit circle.
That's a good idea. What is a unit circle?
Circle with a radius of 1.
Circle with a radius of 1. What else do we know about the unit circle?
Oh, it's a 360
It is, but that's not what I'm looking for.
It's 2 pi.
That's true too, but that's not what I'm looking for.
It's in a graph. It's got. Oh, there's all. We can calculate. We don't want. We're so smart. We're your best class.
A unit circle is a circle with a radius of 1. But I want something else about the circle. It does go into all 4 quadrants. No, it's not degrees or radians. Where does the circle happen? It's centered at the origin. So a unit circle has a radius of 1 and it's centered at the origin. Well, guess what a unit vector is?
Vector that's centered at the origin.
Okay, well, vectors don't have a center. It starts at the origin. So the way we say that is its initial point starts at the origin. All right, and what else about a unit vector?
Positive.
What do we know about a unit circle?
Oh, radius is 1 to the magnitude 1.
Thank you. The magnitude of a vector, of a unit vector, is 1. Gosh, you're so
Energetic.
If you would have seen first period, oh my gosh. No, it has nothing to do with Friday. I'm sorry, I don't normally talk about you guys in first period like this during my 5th period class. I talk about it to their face. It's not just... Okay, so the way that we find a unit vector is, like in this particular case, this vector is at -2, 5. That means I go left 2, up 5. There's my vector. A unit vector keeps the same direction, but we're just going to shrink the magnitude. So it would be like the red vector. It's pointing the same way, but now its magnitude is going to be 1.
Wait, say that again.
This green vector is the vector -2, 5. This red vector is my unit vector, where we have shrunk the magnitude to be 1, but it still keeps the same direction.
Oh.
So unit vectors keep the same direction. All that we change is the magnitude.
And the magnitude would be like the 1, right? That's where it goes, stops there.
No, it's not going to be at the 1 and 1. I'm going to tell you where it goes to. Again, think about, if you think about with a unit circle, remember with the unit circle, it went to 1 here, 1, -1, -1. Any other point on the circle would be somewhere short of 1. So that's kind of where this is going to be. It's like this vector is going to be a radius of my unit circle because its magnitude is going to be 1.
If it was straight, it would be at 1.
Yes.
But it's tilted.
Yes.
Oh, okay.
Correct. Okay. So, now we're going to go through the process. That was just kind of me giving you what's happening, a visual. Now let's actually do the problem. It's not that hard. The way we do it is we take our vector and we're going to divide it by the magnitude of that vector. So we take our original vector and divide it by its magnitude. So guess what we need? We need the magnitude. So what is the magnitude of V? No. The magnitude of V would be -2 squared and 5 squared. It is going to be radical 29. So now my vector, this is what I have to do. I have to plug into this formula. What's my original vector? -2, 5. And I have to divide both of those by radical 29. It's like a scalar multiplication. So this is going to give me the answer of -2 over radical 29 and 5 over radical 29. And we're done. Not rationalize it. So this is a unit vector. It's my original vector divided by its magnitude. That ensures I keep the same direction. I've just changed the length or the magnitude. What you can do if you want to test it, if you take this number and square it and add this number squared, guess what you'll get? Do it. -2 over radical 29 all squared plus 5 over radical 29 all squared equals
What's this gonna be?
you get 1. Because why? The magnitude is going to be 1. That's what I've done. I've kept the same direction, but I've changed its length. So if you're working this problem, what do you have to do? Find the magnitude of V. What's the magnitude of V? Radical 37. So that means my unit vector would be 6 over radical 37, -1 over radical 37. Question. Okay, so now what we're going to do is we're going to go over a different form of a vector. So before we work this problem, let's talk about what that form is. It's called let's see what the book calls it. The book calls it a linear combination of vectors. I always just called it I hat and J hat. And you can see I've worked some problems here with I hat and J hat from my last class. So it's just really how you write them. The book here doesn't use hats, but all of my calculus teachers and my physics teachers in college use the hats. So I use the hats. That's the way I learned it. But so here's what it is. I hat is the standard unit vector 1, 0. So basically, we think of I hat as being like our x component. How much did I move on the x-axis? Right, so if I did like 3i, then guess what? I moved right 3. Because I is just this unit vector. And then if I multiply it by scalar 3, what if I multiply it by -1? Then it's going to go left, right? All those same transformations we went yesterday. This is the I hat vector. J hat vector. That's the standard 0, 1. So that's going to be your vertical component. How much did I go up or down? Right, so it's really not that hard. The math is just a different form. It's just something to get used to seeing. So yeah, that's that. So what we're going to be doing here is we're going to be taking a vector given 2 initial points. And we want to write it as a linear combination of the standard unit vectors I and j. So, again, sounds really complicated, but it's really not if you understand what all those things are saying. So, first thing I need to do, I need to find the components of my vector. So, right now, this vector, again, if this is just me sketching so you understand what's going on the graph. If I'm at 2, -5, my vector's starting here, and it's going to -1, 3. So my vector is somewhere here. First thing I want to do is move my vector into standard position. I want its initial point to be the origin, because it's a lot easier to work with from there. So let's write this in standard form first. So the way we did that, you remember doing that yesterday? We take the initial x, which was 2, and subtract the final x, which is -1. Then we take our initial y, which is -5, and subtract the final y, which is 3. Something tells me I did not graph that well. Did I mess something up? This says my vector should be 3. I did it backwards. The whole thing's backwards.
I graphed mine like that too.
Yes, final minus initial. Sorry. Was I not saying that?
No.
I'm an idiot. Do your final minus your initial. And then your final minus your initial. And so that's going to give me -3. So here's a good teaching point. How did I know I was wrong? Yeah, because I'd already in my head visualized what was going to happen. This graph needs to go left and up. And when I did my subtraction, I was going right and down. I knew I was all messed up in what was happening. But I fixed it. So now I'm going left 3, up 8. And that fits with what I think this should look like as I go from one to the other. Yes. When I put it in this form, that tells me if one point is the origin, this is where I end up.
Okay.
Were you asking something or were you swatting? Okay. Now, if I had to put this in I hat and J hat form, here's what we do. This is going to blow your mind. That's it.
Oh, wow.
That means what? I'm going left 3 from my original unit vector, I. And I'm going up 8 from my original unit vector, J. It's basically like 2 stretches. Right? I've stretched this graph by 3 and then reflected it. And then I stretch this graph by 8. That's the way I think of it.
When it asks for it?
Yep. When it asks for it.
Okay.
You're going to eventually transition to this is how we're going to work all vectors. That's what's coming. Is in this form. Okay, so if I was working this problem, I need to find my standard position vector. I'm going to go final minus initial. That's going to be -6. And final minus initial is -3. So you should have -6 I hat minus 3 J hat. All right, now then we've got 2 vectors. We've got vector U, which is written as -3I plus 8J. And we have vector V, that is 2I minus J. Now that's telling me to find 2U minus 3V.
Okay.
So what are you going to do? You're going to substitute in the I and J form for U and V. Just substitute them in, just like you would in algebra. And then you're going to simplify. So you'll have to distribute and combine like terms. It works just like algebra.
Don't tell us.
Okay, sorry.
No, don't tell us the answer. Let us try.
I just will let y'all try everything blindly from now on. I won't tell you anything. You hear that, Luke? They're a mess without you. Hurry back, Luke. It's great because you know he's never listened to this.
He's not gonna watch
No,
it.
never. Okay.
6. Wait, don't tell. Pause.
Oh, you read it. -6 minus 6.
What are you doing, Versus? Are we supposed
He told me not to grade his math test before we went on our spring break trip because he didn't want me to think less of him as a person.
What'd y'all get, guys? What'd you
Negative
get? Negative what? Negative 13?
I never laughed so hard.
Did you grade it?
Yeah.
You good?
No, not very good.
It's negative 12.
I told him I couldn't think any less of you as a person.
I don't know. What'd you get, Sydney?
Not that.
I didn't get
Negative 12,
Plus
plus
13?
19.
That's what I got. I didn't. What'd y'all get?
That's not TJ.
I got put. Is it not 6?
I didn't get that.
I got negative 14.
Yeah.
All right, so if you're stuck, I'm going to start working this out. So you need to substitute in these two values. So you've got 5 times u, which is I minus 2j, minus 2 times v. V is negative 3I plus 2j. Distribute 5I minus 10j plus 6I minus 4j, which is 11I minus 14j. Okay, so now we get a new kind of question. This question tells me to find the direction angle of each vector. So here's what they mean by that. We're going to find the angle. Well, guess what's going to be a 0-degree angle?
0.
The positive x-axis. That's a 0-degree angle. And then however we rotate, we only go in this direction up to 360 degrees. Just like how we rotated in trig. All right, the only difference is you can't rotate negative. You have to rotate in the positive direction to tell the angle of rotation. So the first one here says, what's the angle of the vector for 3i plus 3j? So again, I'm going to think graphically what's happening here. 3i means I'm going right 3. 3j means I'm going up 3. So this vector is going to be here. When I'm looking for the angle, that angle is going to be that angle. I don't know what that is. How much did I rotate? Well, do I know this value?
Yes.
3. Do I know this value?
Yes.
Yes, 3. So what do I have? I have a
Right triangle.
right triangle, and I'm missing an angle.
3 squared plus 3
You're not missing a side. You're missing an angle. You are missing a side, but I don't need to know the side. I want to know the angle.
Oh no. So we can do sine.
So in relation to this angle, what are the two known sides? Opposite and adjacent. Which trig function deals with opposite and adjacent? Tangent. So we could say tangent of the angle equals the opposite side over the adjacent side. And now how do we solve? You're right. That is 1. How do we solve for theta? We're going to take in inverse tangent of both sides. Inverse tangent of tangent cancels. I got the inverse tangent of 1, which is
Okay, question. Could we do like sine of one of the sides, like sine 90 over that side, if we found that side, and then put that one over that and use the left side? 'Cause I didn't like that.
no.
You can't do that. You see what I'm saying? That's easier. See, like 3 radical 2, and then if you would have done sine 90 over 3 radical 2 over sine theta over 3.
Maybe.
One second.
It seems like a lot more work than what I did, but
Okay.
So if you, alright, so we found the 33, right? And so then you found, what if we found the other side? And the other side is 3 rounds.
that's what she's saying.
But what if we know that the 45, 90 is 1 more round of 2?
Yeah.
It's just 45.
That's what I was fixing to say. I knew from the get-go that was 45 because it's isosceles. There's only one isosceles right triangle. It's a 45, 45, 90. It's the only isosceles right triangle. So, you're not always going to know. Like the next example is not going to be one of our known. So I was showing you how to do it for any example. But you're right. If you recognize this is a 30, 60, 90, 45, 45, 90, shortcut. For sure. Okay? Did that work?
But I'll get it.
Okay, next we're going to look at B. So I've got vector V, which is 3I minus 4J. So again, I'm thinking visually, where's this going to put me? 3I goes right 3, 4J goes down 4. So before I ever start, I know what my angle has to be. It's going to be between 270 and 360 because I have to go in the fourth quadrant. So I know that before I begin. Now, if I draw my triangle here, I'm looking for this angle. I know I went right 3, so I can put in 3 there, and I went down 4. So with vectors, if you want to include the direction, you can, because vectors have magnitude and direction. So instead of this just being 4, we can put -4. Or if you want to remember all students take calculus, you can go that way too. Doesn't matter. It'll work out either way. So now if I'm trying to find this one, I could say tangent of theta is equal to the opposite over the adjacent. Take an inverse tangent of both sides. What do you get when you take the inverse tangent of -4/3? -53 degrees. Is that right? Let me look. That's right. -53 degrees. So what is the negative? Sorry, what are you going to ask?
On those will always be tangent that you use.
I'm going to talk about that in just a second, but yes, most likely. If this is -53, negative tells me which way I rotated at the get-go, right? I rotated the negative direction. This is a 53-degree rotation. But remember, for a vector angle, I have to get the positive. So if I can't write -53, I have to write what was this rotation.
Oh, so.
Well, it was 360, but then I backed up 53. 306 point something.
So it'll always be.
So that's what our answer is.
Yes, 306, 307 is our answer.
It's kind of like with them triangles that could have a 2.
Maybe I'll
Yes.
You know what I'm talking about?
Yes.
Find the other side, the other angle.
Alright, one thing that was asked to me is, will we always use tangent? Well, yes, because what do we know tangent is equal to? Well, we know sine is equal to the y value, cosine is equal to the x value, tangent is the y over x, and what am I given in these vector forms? X and y. So you really don't have to draw this out like I do every time. It helps me to see it visually, to know where I'm going, but if I know tangent is the y over x, I know -4 is my y, I know 3 is my x. And I can plug that straight into the inverse tangent formula because tangent is y over x. But still, in your head, and it's cool how it all works together, in your head, you still need to kind of know what quadrant am I in, because you got to find the correct angle rotated to that quadrant. So if you got negative 53, you would still need to know, I need to rotate to the fourth quadrant. So I still think sketching it out has its benefits. A. 135. Do I need to go over A?
What'd you get, 29? Add,
What about B?
yeah, add that to 180, because you've already rotated 180 because you're in the
B.
third quarter.
210.
210.
Or 209, whatever.
We don't need decimals.
The book's 209.74.